active. Can anybody guess where any of these places are from the images? Yes, first one is IISc. Hi, Suresh. Uh, yes, Mr. Sandeep. It is from IISc. So first one is IISc. It's a very, very old picture. A quick disclaimer: all four images are from Karnataka. So if anybody's from outside Karnataka, from different states, maybe a little bit difficult for you to take a guess. But um, no, it's not a drone. I think you're referring to the fourth image, but these are all places from Karnataka. Anybody can take a guess at. I think the second and third is something you may be able to get. But if you have visited IISc, then I think you should be able to get the fourth image. All right, cool. So the second image is Deshpande Foundation. It's an incubation for startups, mostly in the agriculture, rural entrepreneurship space. So we were selected for an incubation program in Deshpande Foundation, and we were part of this. The third one is Sayadri Farms. If you have heard about Sayadri Farms, this is not from Karnataka, by the way. I'm sorry. Sayadri Farms is from Nasik, Maharashtra. So there was a TCS initiative, more like a boot camp for startup initiatives that we were selected for in Sayadri Farms. And the fourth one is Department of Aerospace Engineering, Indian Institute of Science. So this is right in front of our building, and this is where I'm working from currently, and this is where I'm conducting a lot of research projects. So with that, let's get started. um, so today I'll be mostly covering agri input application and photogrammetry. Anybody can tell me what photogrammetry is? Let's start with photogrammetry using UAV technology. Um, can anybody just take a shot at what photogrammetry is? Given a small description, but or how photogrammetry can be done using UAVs. Before we get started, has anybody worked with UAV systems before? I just want to get an understanding of how familiar these concepts are. Has anybody from the attendees worked with UAV systems, maybe for any kind of research projects, maybe for mapping applications? Anybody here?
I would like to request all the participants to be responsive, either by typing in the chat box or raising your virtual hand so that I will unmute and you can respond.
Yeah, so you can definitely just drop a text on the chat box. I just want to see if you're here and okay, so then I'll start with the basics. I think the previous 2 days, lot about UAV systems would be covered. So at least on the application side, on the agri input side, let me start with the fundamentals. So agri input application is mostly, applying any kind of inputs. It could be agrochemicals, seeds, or any certain things in the agriculture space using UAV technology, right? So photogrammetry, on the other hand, is more of mapping. So it's more of capturing images, capturing sensor data, and then creating maps and creating orthomosaics of all of the fields or the relevant targeted area to again later on process that data for any kind of decision making, right? So this is photogrammetry. So let me start with photogrammetry. So I think you may be introduced to a couple of drone types, UAV types. UAVs, drones, it can be used interchangeably. So there's one type VTOL drones and another multi-copter drones. So Anybody can tell me the difference between these two, or maybe what is a VTOL drone? Anybody knows what a VTOL drone is? You can drop a text on the in the chat. Has anybody heard of VTOL drones? Okay, so I think there are like majorly three types of UAVs. One is the fixed wing. You have all of these, basically your control surfaces. So there are very few rotating parts, but the entire lift is generated by control surfaces, mostly the wings. Those are all fixed wing UAVs. So VTOL drones are more of like a hybrid between multicopters and fixed wings. So you have some kind of a vertical takeoff and landing. That is what VTOL is an abbreviation for. So vertical takeoff and landing capabilities, and then it can switch to fixed wing mode mid-air, right? So that is what a VTOL drone is, and a multicopter drone is mostly just rotors that will control and guide the drone for most of the most of the missions, right? So VTOL drones are mostly used in photogrammetry applications when you are required to cover large areas, right? Because it's just inherently more efficient than multicopters. Because once it switches from the multicopter mode to fixed wing mode, you will have very few rotating or energy consuming actuators. So and the actually the control surfaces will be generating the required lift. So effectively what is happening is you'll be reducing the energy consumed by the drone to cover distances, right, or to stay afloat, right? So VTOLs are mostly used for long range surveillance mapping missions, and for just to cover large areas at much quicker speed. While compared to multicopters, it's used for precision mapping. So let's say you have a very small area, maybe 2 to 3 acres, and you want to map 2 to 3 acres of agricultural farmland, and you want high accuracy data, high resolution imagery, right? That is when you would use multicopters, because they can fly at a much lower speed and cover smaller distances with high accuracy imagery, right? So this is predominantly why the difference between VTOL and multicopters, and how you would choose. Let's say you are covering 60 to 100 acres, then ideally you would go for a VTOL drone if you have that kind of space to take off the drone, land the drone, and because these are much bigger systems than the multicopters, right? So that is where you would typically go for VTOL drones. And if at all you want to just survey a small patch of land, maybe 5 acres, 6 acre land, right? 10 about 10 to 20 acres of land, and you want to do some kind of a mapping, you want to get an understanding of that farmland, what are the different crops that are grown, what is the health of the crop, and so on. That is when you would go for multicopters, right? So photogrammetry in a nutshell, this is how it works. So there are images captured by UAVs. So UAVs, mostly drones. So these images at regular intervals, right? These are captured by the UAVs, and these are mostly done either through manual flight or predominantly using autonomous missions, right? So there are a couple of softwares that you can use to plan a mission, plan a path plan, a flight plan over the targeted area, and determine or set how many images must be taken in that particular targeted area, and in what kind of path or a navigation path plan the UAV must follow to survey the entire farmland or the targeted area. So once you set this autonomous mission, then the UAV takes off and it starts capturing images, right? So with these images, you have these are all just images, maybe like 200, 300 images that you would capture for a small piece of land of 5 acres, 6 acres. Now very difficult to do any kind of analytics, right? Because there may be certain overlap between the images, maybe a little bit of distortion in these images. So very difficult to process 300, 200, 300 or more images, right? So you would need one single large image, which is called orthomosaic. So you have heard about mosaics, right? Like mosaics is basically composition of smaller parts, smaller images or paintings or parts, right, to create a bigger picture. So that is what an orthomosaic is. So you take all of these images, stitch them together, and then you have a large image that you can then process and then run any kind of analytics on, right? So there are multiple softwares to do this. So one of the popular ones are Pix4D, Drone Deploy, Agisoft, and so on. So you can just upload the UAV images, which are geotagged, geo-referenced images. So basically, what that means is the image will have the GPS data of the drone when it captured the image, right? So basically, the GPS information of that particular aerial image is tagged, and those images are what will be used by these softwares to create these orthomosaics. And the orthomosaics are then used by any kind of GIS tools or any kind of data processing pipelines that you would have developed to run any kind of analytics. It could be analytics such as yield monitoring, yield prediction, health monitoring, or just counting the number of crops, counting the number of trees, or detecting what kind of crop is grown in that particular targeted area. So this particular image is from Indian Institute of Science. This is Department of Aerospace Engineering, at least a part of it from the top view. So you can see the clear delineation of these trees can be done, and then you can run any kind of algorithm to detect these trees or count the number of trees and do any kind of photogrammetry processing, right? So a couple of bottlenecks that this particular industry is facing right now: mapping, agricultural mapping or precision agricultural mapping. So mostly it is linked to data pipelines. I'm not going to go too technical into this, but just to give you give you some kind of perspective. Imagine you're surveying just 6 acres of land, 6 acres of farmland, and you're capturing 300 images, which will be around 5 to 10 GB, depending on the resolution of the images. So now storing all these images for this small farmland itself is a task, right? Let's say you want to put it in cloud, and then you want to process all of these images. And how do you transfer these images? Maybe the big orthomosaic, which is around 4 to 5 GB, right? This big image. How do you move it around, right? So a lot of these pipelines and storage, cloud storage facilities must be in place, and it should be capable of handling this kind of applications. So currently, let's say you're mapping at a village level or a taluk level, right? Using these UAVs. So the number of images that you'll be capturing is significantly higher. So you'll be capturing in thousands of images, right? And storing them, processing them, and then handling those images efficiently is a bit of a challenge right now. That is why if you see a lot of these, these companies are facing a lot of challenges when it comes to handling all of this data, maybe in real time or maybe after the missions, right? So those are some of the bottlenecks. So I'm going to quickly come to the sensor systems that are used. Can anybody tell me the difference between RGB camera, multispectral camera, and a hyperspectral camera? I think in the agricultural space, you would have used some of these sensors, at least RGB sensor, to monitor any kind of crop to get any kind of crop analytics, multispectral camera to get any kind of indices, vegetation indices, or so on. So anybody can tell me the difference between RGB, multispectral, and hyperspectral camera? Just drop a text in the chat if at all you have some kind of familiarity with these sensors. Resolution, I mean, it depends on camera. I think you can have a RGB camera, multispectral camera, and hyperspectral camera of the same resolution. You could have some similar resolution, but yes, for sure there will be resolution differences. I think with RGB it is very easy to get 4K resolution or 1080p resolution with the sensors, but with multispectral significantly difficult. So yes, Dr. Kazi, that is one of the differences. Spectral difference, yes, that yes, Mr. Akash. So that spectral difference is the major difference. So the number of spectral bands that you capture with RGB camera. So RGB is mostly three spectral bands, right? Red, green, and blue. So when it comes to multispectral, it could be ranging from 4 to 10 bands, right? So predominantly you'll be capturing, apart from RGB, you'll be capturing NIR, which is near infrared, or some kind of a red edge band, or there are multiple bands that you can capture with multispectral camera. So that is why you can see there are 5 lenses here. So these are for the 5 sensors. So this is a 5 band multispectral camera, and you have these 5 sensors integrated in one camera. And when it comes to hyperspectral, the number of bands increase significantly. So there are in hundreds of bands, right? So in that spectral, whatever the range that you have, you just have more bifurcation in the bands. Finer bands are being captured by hyperspectral camera. So what could be the applications of these cameras? Could you please um, take a guess on what may be the application specific to precision agriculture? Specific to agriculture, what could be some of the applications of these RGB, multispectral, or hyperspectral cameras? Yes, 3 bands in RGB and hundreds of bands in hyperspectral. Yes, precisely. So applications. So can you take a shot at what would be the applications with RGB? Definitely, with more spectral bands, more spectral resolution, you will have more applications that you can tap into, more capabilities that you can tap into. Okay, with interest of time, crop monitoring, yes, yes, Mr. Boyer. Crop monitoring is one of them. I think all these cameras, all 3 of the cameras, can be used for crop monitoring because you know, if at all you want to get really specific, let's say what kind of crop monitoring you can do with RGB camera. So let's have a look at that. So one is crop identification. To a certain level, with just RGB imagery, you can detect different types of crops. Although there are certain crops that are very similar when it comes to spectral signature that you may capture from aerial imagery. So there are certain crops that are very similar, but most of the other crop types, it's very easy to identify or detect with RGB imagery. Crop count is one thing that you can easily do with RGB imagery. With high resolution imagery, you can maybe count the number of stems in sugarcane plantations, number of trees in areca plantations, number of trees in pomegranate plantations, pomegranate farmlands. But yeah, so crop count is something that you can do easily. And biomass estimation is basically, density, or what is the kind of mass of the agricultural produce, right? So these are some of the basic capabilities that you can leverage from RGB. When you go to multispectral, since you have more spectral bands to play with, so what you can do is there are certain vegetation indices that you can calculate. So it could be NDVI, NDRE, NDWI. So these are some of the vegetation indices that will indicate certain factors, certain features, or certain data about the crops. So vegetation indices like NDVI will tell you what is the kind of crop stress. NDWI will tell you some kind of water stress, water index, right? So these are some of the things that you can capture with multispectral imagery. You can play around with the bands and the spectral signatures and combine them in certain formula to get different vegetation indices. right? So NDVI has a different formula to combine the spectral information. NDWI has a different, NDRE has a different formula. So depending on that, you would get different kind of information, different kind of correlated information of the crops, right? So this mostly using the reflectance, the light reflectance and the pattern. That is how it is captured, right, in a nutshell, if you're not going into the technical details and in depth, right? So crop growth monitoring is something, depending on the stress or depending on the crop health that you'll be monitoring, that you can capture from multispectral images. You can definitely monitor how your crops are growing. Is there any kind of stress anywhere detected? And hyperspectral is it gives you significantly more number of bands, so you can actually look into soil analysis, right? That is something that is possible with hyperspectral, and there's a lot of research that is being done, a lot of libraries that is being created for soil analysis. Early disease detection is possible because you'll be capturing a lot of spectral signatures that you can correlate with any of these diseases or pest infestation, right? It could be some gases that are being released, or it could be some kind of chlorophyll content that is being affected, that can be captured by high resolution imagery with more spectral signatures, right? And that is something you can definitely correlate to. So a lot of these models and libraries are being built. In fact, in IISc as well, we have taken up a couple of projects with ICER and NIT Calicut. There's some kind of a collaboration project that we are working on to actually detect early onset detection of diseases and pest infestation, mostly using multispectral cameras. So let's have a look at the data acquisition. I think I briefly mentioned how you would fly a drone over a farmland and then do it, but this is in a nutshell, what that would comprise. There's a mission planning. In mission planning, you use any of these software that are available open source, or some of the softwares that third party vendors provide. So that is where you set the altitude, the speed, the overlap of images, the side lap of images that will be captured. And if you can see here, this is the path plan that will be generated by the mission planning software. If you give some kind of a target area, basically area of interest, and this is how it would generate to accommodate all of these flight parameters and capture all the images, right? So when it comes to equipment setup, with RGB, there's not much of equipment setup, but when it comes to multispectral cameras, you will have to probably, I mean, you will definitely have to calibrate it before flight and probably calibrate it again after flight, right? So there's this calibration process that is required. That is mostly part of the equipment setup, and then flight path is being generated by the mission plan, and then takeoff and automation. That is how you capture the data, right? So one of the projects that we had taken up was mapping pomegranate farm and then building models for yield prediction, health monitoring, and weed mapping in pomegranate farms, right? So this was mostly the images captured on ground, and these were the aerial images from the UAVs. um, so some of the parameters, some of the information that I've just mentioned here on the slide of the entire mapping mission that we had for pomegranate farms. We captured more than 5 farmlands in Karnataka, and what we did was we captured over the course of 6 months at regular intervals. So every 20 days, we used to go and capture images of these farmlands, and this is what we used to create all of these algorithms for these artificial intelligence models for yield prediction and health monitoring. So I'm going to get to that now. But yeah, so mission specifications. So this is from 25-meter height, about 124 images for just a 3.5 acre land, right? About 124 images is what you will be capturing. This is again, ties back to the data pipelines and the storage capabilities, right? This is how it would affect 4K resolution. That's just the resolution of the images, and the entire mission took just 11 minutes to capture 3.5 acres of land. So about 630 trees in this entire farmland. This is how you, after generating that orthomosaic, you would feed it into a GIS software. This is from QGIS software, and you would extract some of the physical features. This is how you would run some kind of data analytics on the imagery, right? um, this is a very manual process. You will delineate each and every tree, you will calculate the height, and we validated with the manual height, and we saw that there's very close correlation, and it is pretty accurate from the point cloud that was generated by all of these images. So, and this is NDVI. This is from the multispectral data. What I mentioned, NDVI is one of the vegetation indices. Um, and canopy volume. So some of the physical features that we extracted from the images. So how we are going to automate this is what we looked at next, right? So basically all of this is manual and time consuming. So every tree you may have to delineate, or every farmland you have to delineate, and then process it in GIS softwares, right? This is not really scalable if you're doing it at village level or taluk level, right? So what would you do? You would develop an end-to-end data pipeline, or an analytics platform, where all of these different processes, the image pre-processing, post-processing, analytics, and all of that is integrated in one single pipeline, right? So just replacing the traditional pipeline with an end-to-end analytics platform. So Agriome is one of the POC platforms that we developed for end-to-end analytics. So what it does is, I'm not going to get into the details here, but YOLO V5 is one of the deep learning models that you may have heard of. This is very popular object detection models. We leverage that, and we built one of our own versions of the object detection models as well. So once you detect the trees, you extract the features, and then you push it to some kind of a machine learning model that will predict the yield of the trees, right, based on the physical features that you have captured from the images. So this is how crop detection works. Once you train the model, this is how the detection would look like. And once you extract the physical features from those images, this is how you would get. For each detection, you will have height, diameter, and many other physical features that you would like to extract from the images, right? Volume, NDVI, or any other vegetation indices that you can capture. So this is the crop detection side. This is an analytics platform that we have developed in IISc. So each tree has been detected, and then you can actually click on individual trees and get their analytics. So a bunch of analytics that we provide on a farmland level, and this is what we are now extending to village level, taluk level, and just scaling this entire platform. So very similar to this, the health monitoring. So it just uses multispectral data instead of RGB data for yield prediction. So multispectral data, and instead of object detection, we have some kind of a semantic segmentation. So it is both, basically, instead of drawing a bounding box, there was a box drawn around the trees here. So this is an object detection model. And if you see here, it's delineated exactly, the boundary of the tree is delineated. So this is using a segmentation model, right? So it exactly delineates the object of interest, and then you can capture the vegetation indices or any kind of reflectance pattern from the detections, and then do analytics at scale. So this is one of the health monitoring features that we have developed, and this is a bit of another model that we have developed for weed mapping. It gives you the output of the weed, or the heat map of the weed that is present in the farmlands. So basically works similar to segmentation model, but apart from that, we do have some kind of models that will leverage some of the chi bands and the exr bands in the visible spectral range to get the weed map. So on top of this, what we also do is, each of these clusters. So if you see these red clusters here, which are indicating the weed infestation, right? So these weed clusters are geotagged, and they are provided to ground vehicles to remove or address these, right? Maybe spraying of herbicides or so on. So we create a path plan to remove these weeds in a farmland for the UGVs. So very optimal path plan using this aerial mapping, right? This is how you can have UAV UGV synergy, right? Once you capture the images, once you process the data, you take the data and then feed it to UGVs, and then they will do the task of removal of weed. Some kind of a synergy between these two, right? And there's one interesting project that we have taken up, which is long-term farm registration. So let's say you capture the same farmland image after 6 to 8 months. So the tree physical features would have changed drastically, the color of the tree or the size of the tree. So detecting the same tree using computer vision models would be difficult, but the pattern in which they're growing, so let's say the pattern in which it is sown, the trees are sown, that would never change. Basically the spot where the tree is growing would never change with respect to their neighboring trees. So that is the pattern or a geometric descriptor that we would capture, and that is how we will compare two images, maybe that have months of difference or years apart, right? Two images that are years apart, but we can still tell this is the same exact tree from both the images automatically. So we won't have to do it manually, selecting each individual tree from the image and telling this is the exact same tree from these two images. So we would train a model to detect the geometric representation or geometric descriptor of the tree. So what I mean by that is, let's say this is a tree of interest and this is the neighboring trees or some gap between the trees that are detected, right? So what it would do is, it will this is the distance vector and the angle vector that we will generate, and the pattern in which it is growing is what is, again, is stored as information, or some kind of an identifier for that particular tree. So if you come back after years later, you can still detect the same tree from those images, right, if the neighboring trees are still existing. um, so that is how we do it. Long-term farm registration, very interesting project. I think this would definitely help in monitoring orchards or huge farmlands at scale, where you don't have to manually check for each tree, and monitor the growth of each and individual tree. So these algorithms are what is going to automate that entire process, right? And one of the government collaboration projects that we had taken up, this is mostly for real-time crop classification. So while the UAVs are flying over large areas, maybe at the village, taluk level, district level, if you're flying these images, how can you capture the data of individual farmlands, what crop is growing, and so on? This is more of a collaboration POC that we are still exploring. So let's come to the spraying, the agri input application side. So in input application side, mostly drones are used for spraying applications, spraying of agrochemicals, pesticides, herbicides, and so on. So this started out way back in 2000, in Japan. I think 1997 in Japan, where they were using these helicopters, remote controlled helicopters with agrochemical spray tanks to spray pesticides. Right. So Yamaha RMAX was one of the oldest remote controlled drones or remote controlled systems that were used to spray chemicals. So from the single rotors, then soon they upgraded to multi rotors. So here you can see there's a long boom under a drone, and this particular drone has these sprays right underneath the propellers. So can anybody tell me what would be better, a long boom or one that is right underneath the propeller? Can anybody take a guess? What is the better way, or what is a better system, and why is it a better system? Is it the long boom one, or the one that is right underneath the propeller? First one or the second one? Second one. Okay. So why would you say that it's the second one? Reason for that as well. If you're suggesting, or if you're telling that it's which one is better, also include the reason for why it would be better. First one, more area covered, Mr. Akash. Yes, precisely. More area covered by the boom, because you just have a longer boom and then you're covering more area. Yes, so you would say first one is better. Okay. Second one, when you say distributed, what do you mean? Distributed as in, like, is it evenly spread, or is it coverage, or what do you mean by distributed? Or anybody else, if you want to take a guess. Yes, in a distributed manner. Okay. All right. All right. So yes, more area covered in the long boom sprayer, but at the same time, you will have some kind of what do you say? These chemicals can spread easily, and it may reach neighboring farmlands, or just spread of these chemicals with the wind. And there's going to be a lot of drift associated with a long boom sprayer, like in the one in the first image, right? A lot of drift associated with it, and that is not really preferred when it comes to agricultural spraying, because one is drift can lead to application of pesticides in neighboring farmlands or in areas that you're not interested in applying pesticide. And the other one is you will not have concentration of that kind of concentration of pesticide falling over the over the crop, or the any kind of crop area or the leaves, right? So when it comes to the second type, when it is right underneath the propellers, right, you have more of this concentrated spray right underneath the drone, and you have better density of these chemicals that are touching the uh, region of interest, right, crop of interest. So preferably the second type of drone is what is used, also in practice as well. But yeah, some of the bottlenecks I wanted to address in the agri input application, because I think drone spraying in India is picking up at a very fast pace. Government initiatives are promoting a lot of these a lot of these services or demos or just awareness creation. And also a lot of these service provider companies have set up all over the country to provide this kind of agri spraying for farmers, right? So it is picking up pace, but we did spend about 10 to 12 months on ground building softwares, operations management softwares and platforms for these agri drone service providers. So some of the challenges that we detected was that indigenous development of these drones is a major issue in India right now. So because most of these drones are just procured from China and assembled in India and then are being used, right? Although the Indian regulations say that these import from Chinese drones are not allowed, and you have to have some kind of DGCA certified drones to fly, so on. But there's still a lot of these loopholes, a lot of this gray area these people are leveraging, so to import and assemble Chinese drones. And even the flight controllers and everything are being imported and being used here. So indigenous development is something that is one of the major bottlenecks in India. So we need a lot of research, a lot of commercialization of all of these research projects, specifically when it comes to UAV technology, and that is something that we are also working on. So I'm going to get to the project that we have taken up in IISc soon. But yeah, this is one of the major bottlenecks. So, and also economies of scale. What that means is, right now there are not a lot of customers in India to purchase a lot of these agri drones. Right, there's maybe farmers are reluctant, the service providers are not seeing the value that they're getting out of purchasing all of these drones and then providing as a service. Drone as a service is gaining traction, DAS, right? So drone as a service is gaining a lot of traction, but then they don't see that much of value to purchase a lot of drones, place orders for multiple drones. Although government has placed 2000 drones, and I think they're expecting to get around 15,000 drones in the next couple of years. But that is a government initiative. From the consumer side, from the customer side, that there is a lack of pull, because it's still a new technology, a nascent technology in India. So when that is the case, uh, obviously the cost of making the drones in India is going to be significantly higher compared to Chinese drones. So this is one of the other bottleneck that the agri drone ecosystem is facing. And another thing is unpredictable mission conditions. This is something that we observed firsthand when we were tagging along with these service providers. So there's going to be a random pole, a high tension cable on top of the field, or there'll be one small house in the middle of the field, or there'll be some pits here and there, so the terrain following feature will not work properly. And so very unpredictable. Indian agricultural conditions are very unpredictable, mostly because the lands are fragmented, and also there is no standard practice as such that is being followed, right? So when that is the case, it's very difficult for these systems to be reliable, right, in these Indian agricultural conditions. So that is one of the major challenges that the pilots are facing on ground, right? And you need some kind of tailor-made solution. So they need some kind of solution just to address high tension cables as a problem. They want another solution just to address one tall tree in the middle of the farmland. How do you maneuver around it and then spray? So a lot of tailor-made solutions that are required for Indian agricultural conditions, when compared to places abroad. Maybe if you take USA, where you have 200 acres of land, 400, 500 acres of land, and just even ground and evenly spread across a huge area, right? So that is one of the major challenges the agri drone ecosystem is facing right now. And I'm going to skip this part. This is mostly the onboard computational system that we can use to actually make these drones more intelligent. You can remember ROS or Drone Kit. These are some of the frameworks that you can use to make it more intelligent, right? So yes, so this is one of the projects that we have taken up in IISc. Currently, we are working on, and we have raised a couple of research grants to take this further. Um, so areca plantations, right? It's very difficult to spray agrochemicals on the areca seeds or the leaves manually, and it's a very tedious process. And since there is a lack of labor, skilled labor, there's a bit of labor shortage. So it's very difficult to do this effectively, right? Spraying pesticides on areca plantations. So this is one of the problem statements that we have taken up, and this is something that even the drone companies are addressing. So a lot of these orders in South Indian demography are getting placed by areca plantations, areca growers, right? So and so the service that is being provided for areca plantations is being charged 3x, three times more than what they would charge for a field crop like sugarcane or paddy, right? So for areca plantations, they're charging about 1,500 per acre. For field crops, is anywhere around 300 to 500 rupees per acre. This is what the drone service providers are charging, right? So majority of the orders are from Areca. Maximum revenue is being generated by Areca, and also majority of the crashes, drone crashes, are on Areca plantations. Mostly because there's a lack of line of sight when it comes to trees, taller trees, and very difficult to maneuver over the trees because the height of the trees are pretty uneven, right? In mostly in areca growing practices, you would grow a set of trees, and then after maybe 5 or 6 years you will grow another set of trees in between the areca trees, right? So there'll be a lot of height difference when it comes to areca plantations, canopy height difference. So for a pilot to maneuver over those, it's very difficult when he is doing manually. So what we are building is some kind of a computational board that can go on the drone that will assist the pilot in maneuvering or in maintaining that height. So in real time, the board will assist the pilot to maintain the height over the crops, and but the pilot will also have some kind of control over how the drone is moving. Right, left, forward, back is something that he can control, but the height of the drone is controlled by the system that we are developing, that will go on the drone. In real time, it will control. So this is one of the major projects that we have taken up, and I think this is something that is going to benefit the agri drone service providers, because it will reduce the skill set required by them. It will reduce the skill set required by the drone operators, which is one of the major challenges this entire ecosystem is also facing right now. Right, so there is a lack of skilled pilots as well. Um, so just market impact, a lot of areca plantation in the South Indian demography, and so that is why it's very important to address this right now. Variable rate application. So what is variable rate application? It's basically you varying the rate of or you're varying the application of pesticides or any other inputs based on the conditions that you're measuring, right? The agricultural conditions or agricultural data inputs that you're gathering. So if there is more crop stress in one region and less crop stress in another region, so you vary the rate of pesticide that is sprayed in one region compared to the other, right? So this is called variable rate application. And how we do that with drones is that we capture, again, it comes back to photogrammetry, right? You capture the map, you capture the entire data of the farmland, and then what you do is you run analytics on that, and you capture where there is stress and where you need more pesticides to be sprayed, and then you GPS tag them, so that your UAVs or your drones will know exactly where to go and spray more and where to spray less, right? So this is something that we are still working on. This is the, I think, next big thing on when it comes to UAVs, because currently UAVs are mostly used to spray evenly and uniformly in the entire farmland, and it is mostly done manually, right? So there is no varying the rate of application, which is, I think, is going to be make it more efficient and reduce the wastage of chemicals or overuse of chemicals and so on. So that is the next thing, next big thing in the agri drone side, agri input application side at least. That is something that we are working on right now in IAC as well. So yeah, scope of UAV technology. Basically, we still need to explore UAV and satellite synergy. That is something that is unexplored as of now to a great extent, right? Because not all the work can be done with UAVs alone. You cannot take UAVs for mapping out villages, mapping out districts end to end, right? With high resolution imagery. That's not feasible, right? Economically feasible for doing any of these things. And even if you do, you can't keep on doing this every other month, right, at regular intervals, because that is what is required. The agricultural conditions change every month, every week. So you can't be using UAVs to do surveillance at large scale. So that is where you have to find some kind of synergy between UAV and satellite. And satellite, it's with alone satellite alone cannot get high resolution imagery. So if you can bring in that kind of synergy where UAV captures some of the information and then you scale it, you extrapolate with using satellite imagery. That is something that is yet to be really researched on. And UAV UGV synergy is one of them I mentioned in weed removal and mapping. But something more than that must be explored still. And yeah, so these are some of the things, and big data analytics for sure, because you'll be capturing huge amounts of data, and swarm technology. So with that, I think I'm gonna conclude this a brief introductory talk on UAV application in precision agriculture. Mostly covered two aspects: input application and photogrammetry. So yeah, that would be from my side. This is my LinkedIn ID, QR code you can scan, and that you can hit me up on neeraj@artpark.in. So thank you so much for giving me this opportunity. Yes, with this I'm going to be concluding.
Thank you very much, Neeraj. Now I request participants, if you have any questions, you can directly.
Yes,
You can
you
raise
can
your
unmute
virtual hand.
yourself.
Yes.
You can drop a text or unmute yourself as well.
Just raise your virtual hand. I will unmute you, please.
Right, right.
Any questions? If there are no questions, we'll wind up the session.
Yeah.
Any other questions? Just let me check in the YouTube channel if there are any questions. No, Neeraj, as of now, there are no questions. I just want you to ask what are the major inputs that you want to suggest for beginners who want to be involved in this agriculture using this UAV and drone technologies? What are the prior things and preamble things he should know?
Yes, yes, sure. Um, yeah, so I think when it comes to these two applications, right? When if at all you want to get into the input application, like you want to spray chemicals, so the prior, I think, knowledge or requirements one would require to have is just a basic understanding of how these agri drones work, the system integration side. The different components, flight controller, motors, ESCs, and so on. The system itself, how the drone works, and how you can leverage the capabilities of the drone is something that you would be required to know. This is something I think you can definitely get from the internet directly. There are a lot of tutorials, a lot of videos, and then you can just follow that. And there are also a lot of training that is provided by RPTOs and so on. You can enroll to some of them. So that is one thing. And then again, it comes down to mastery of operating the drone, how good you are when it comes to operating the drone. When it comes to photogrammetry, I think it is automations mostly. So it's just software knowledge that you would need, it's very software specific. Whichever mission planner or whatever ground control GCS software that you're using, if you have a good understanding of that, again, online is a very good source to get that kind of understanding. But for analytics, that is where you will be required to know programming languages. You will be required to know computer vision if you're doing some kind of analytics based on imagery, because that's going to be mostly what your work is going to be. Computer vision side, object detection, deep learning, and so on, right? So again, internet is the best source, something you can definitely learn, and that is what even I did. So any of these applications, any of this particular field you want to get into, I think all of that can be done through the internet at this time, at this age, this internet age.
Thank you, Neeraj.
um, yeah, one question there, I think
Yeah,
from Mr. Shiva Prasad. Do I provide training? Not exactly training. I'm not sure what you mean by training. Is it drone training or drone flying or training in terms of any of these applications? But definitely there are a lot of these programs that IAC and professor conducts, workshops, do drone workshop, and so on. That is something you can enroll for, a very good introductory session to get you started. And post that, definitely through collaboration and through some kind of projects, we can definitely take it up. Drone training, that is something I think RPTOs provide, licensing and training. So that is something that we don't provide straight away. But along with other things, yes, we do involve you in certain things if at all we are working on some projects. Assembly training sessions, yes, they happen during these do drone workshops. So we conduct these workshops regularly in IAC. Professor Omkar heads all of these do drone workshops, that is collaboration with HAL. So that is where we call in all of these faculty members, students, and so on. And this is like a 3-day 4-day workshop where you get to train on mapping, and you get to train on assembly of the drone, system integration, application, and all of that. It's like an introductory workshop. You can definitely check it out. It's called Do Drones. Yeah. On hyperspectral in Karnataka, as of now, I'm not sure. IISc is also, in fact, not doing any kind of hyperspectral imager research on hyperspectral imagery, at least in the agriculture side, using UAV technology. Using satellite imagery, yes, there are a couple of professors in IISc as well who are doing this. But I think Rahuri University is where they're using drones and hyperspectral cameras for agriculture applications. You can check that out as well.
thank you, Neeraj ji. Any
Thank you.
other
Thank you so
questions
much.
or any other offline questions we can take? You can communicate with him through email, or you can contact us also. We'll communicate to them, and what best possible way we can do help you, we will help. Is that okay, Neeraj ji?
Yes, yes, for sure. You can drop in a mail or get connected on LinkedIn. Either ways work. And thank you for this opportunity. Thank you for being a very good, great audience. Thank you so much.
Thank you, Neeraj ji. And one more question from Dr. Yukesh Anwad, sir. Any outsourcing work done from your side? Like,
Outsourcing, I mean, most of these research projects are happening in IASC, so not a lot of outsourcing work that we do. And it's mostly on the computational intelligence side, so it's on the algorithm side and stuff that we are doing. So not a lot of outsourcing work that we are doing as of now.
okay, okay. Thank you, Neeraj ji. Thank you once
Thank you.
again for being part of this 3 days online workshop. And we hope to see you in our future programs also, either it's physical or online. And I would like to thank Shri S.N. Omkar, Dr. S.N. Omkar sir, also for his support throughout academy year and all the programs of academy. And I request you to drop your YouTube channel and the product, whatever the details are there, so that I would like to share that to all the participants. They can contact you and they can have a look at.
Yes, I will do that. think it's Grow Zone. Dropping this in the chat here. You can check that out. One of the platforms that we have developed, and we are taking it forward. Happy to hear any kind of feedback on that. Thank you.
Thank you, Niraji. So we'll be having the next session in another 5 minutes. The technical person, Mr. Nagur Kani, is joining. So he'll be talking about the drones and its operations. He is also working on real-time projects. He will be explaining about those challenges that they have come across. Stay with us. Meanwhile, if any other questions, you can drop down in the chat box. We have requested all the participants to resubmit the Google form. Those who have edited, they can ignore, and those who have not edited, they can submit it once again. It's very good morning, Nagur Kaniji. Namaste. You are mute. Please unmute.
Good morning, everyone. Namaste.
Namaste. So on behalf of KSTA and on behalf of Manage, I would like to welcome Mr. Nagur Kaniji to deliver today's session. He is a most experienced person and scientist working in the Karnataka State Remote Sensing Science Center Application Center. And he is involved in many drone related projects related to inline department like agriculture, horticulture department, and other supporting departments. With this brief introduction, I would like to welcome Nagur Kaniji to deliver once again this session.
Thank you, Mr. Umesh, for the nice introduction. So I will share my presentation. Will initiate it. Thank you. If my screen is visible?
Yes, visible.
Yeah. So good morning, everyone. So this session I would like to discuss with the different fixed wing operations and aerodynamics. Under that, what are the types of fixed wing drones available? So its parts and what are the terminology associated with that, and operation and maneuver of fixed wing drones, how it played performance, how we can improve it, then introduction to the mission planning and the drone flying and navigation through ground control stations. Obviously, pros and cons of the fixed wing drones. So application of UAVs, I will like to point out some use cases what we are using at Karnataka for the GOK department, how the Karnataka government is using. So this is the outline of our session today as given to me. So there are 4 fixed wing drones we can typically classify. They are gliders, powered gliders. So they are rolled out now. They are initial time of these drones at the time of evolution. It happened. Now mostly we are using electric fixed wing or fixed wing VTOL. So it is vertical takeoff and landing. So what are its main parts? How it's evolved further? We would like to discuss it. So gliders, they are uh, typically a fixed wing drones. It is rely on mainly winds, so air currents, it to stay airborne. So they are used as it was earlierly. Initially, they start with this kind of fixed wing drones at the time of testing and initial stages. So still people are using it. So it has because it does not require any battery. So wherever the wind currents favors, wherever the weather conditions favors, so people with the skilled skills, they can able to do it very easily. So the gliders, but in India we are not using it much because if you are working on mapping, because you need a controlled motion of your flights, so we cannot rely on any gliders, especially mapping. So it is more friendly on taking videography and sightseeing, or maybe just surveillance, those kind of things. It will be useful. So powered gliders. So the name itself indicates that the gliders having with the power. Uh, it is powered by electric or some other any source of energy. So power gliders, they bridge the gap between traditional gliders and motorized fixed wing drones. They share the aerodynamics of gliders but come equipped with motor, providing the ability to take off independently and maintain flight even with less than the ideal wind conditions. So they are powered but not for a, like it is not powered like a fixed wing drones. It is slightly powered, so a basic maneuvers we can do. So still the most of the cases we rely on winds only. So since it is powered, so we can use it for long range and we can define some specific flight paths. So in that case, we can use it. Now come to electric fixed wing. They are now popularly used everywhere throughout the world. So they are powered by electric. They are eco-friendly. Hence, it generates minimal noise. So it is perfect for anything in urban areas, populated areas, or a wildlife surveillance, forestry mapping, etc. So it can take the batteries having the long endurance. So we can fly more than 2 hours. So in India, we have the drones are having fixed wing manufacture. Drones having more than endurance are available. But however, the since the electric motors and batteries, we have to use more skills and more complicated technology to manage the systems to make the drones optimal performance and its safety. So coming to the most famous fixed wing VTOL. So everybody prefer this fixed wing with the additional capability of vertical takeoff and landing. So it is It is the latest cutting edge technology. So it merged the long range capability of fixed wing drones with the superior maneuverability of the multi-rotor drones, especially during the takeoff and landing. So during takeoff and landing, it acts as multi-rotor. Rest of the time, it is act as the fixed wing drones. So we can utilize the advantage of both multi-rotors as well as the fixed range, fixed wing drones. So it is perfect for applications, whatever we are working, it's for mapping, okay, for complete any kind of photogrammetry survey, and even for due to now we can do very confined areas, we can do the takeoff landing. So obviously we can use for any kind of locations for surveillance, rescue operations. So how this VTOL drones achieve vertical flight is, it is through various mechanisms, including the tilting propellers. The propellers are additionally added on the wings or employing dedicated VTOL rotors for takeoff and landing. So this is the currently Indian manufacturers are mostly working on it. Trinity F90, Idea 4G has it. So RF unmanned aerial system they are manufacturing. So now this become more indigenous. So this fixed wing VTOL. So even though the technology is more complicated, we are able to do it. So now all the products are fully manufactured by Indian companies, and so we can use it very comfortably with at a lower cost. So now this we are going through little details of this terminology. What is the anatomy of drones? So minimum basic concepts of the fixed wing drones, how it operates, how it maneuvers. So fundamentals of flights, all one should know before getting into the operation on it. So the obviously the course offered by the DGCA is including those parts for the pilot training. So here we will touch the outline, the minimum, some terminology we will able to keep it in our memory, or we will keep it in our mind to get it further, plan it. So obviously, yeah, fixed wing is almost similar to a aeroplane, the aircraft. So it has a propeller, it has a fuselage, it has a loading gear, it has a wing, it has ailerons. So in the tail, it has a rudder, elevator, stabilizer, both in vertical and the horizontal. So these are the terminology we are more familiar. We should keep it in always in mind that this vocabulary, this for example, this technical terms to operate more efficiently. So what fuselage that it is a central body housing battery, motor and control systems. Wings. So it is the airfoil generating lift for flight, designed for different flight characteristics. So for long range, and it is the main portion that control the maneuverability. So tail, the tail explained it is comprised the horizontal stabilizer for pitch control, vertical stabilizer for yaw control, So what is pitch? Yeah, I will explain in further slides. And rudder for directional control. So landing gear. So support the drone during takeoff and landing. So the options include fixed or retractable landing gears. So motor, the motor is major part. It propels the drone forward using electric power most of the times, or any other power sources. Propeller rotates to generate thrust, creating airflow over the wings for lift. So vertical, if VTOL have more than one propellers, a fixed wing have only one propellers on the nose. Fixed wing without VTOL. So battery, obviously everybody knows what is the use of the battery, what it does. So mainly it powers the motor and electronics. The electronics, the power required for payloads, payload movements, operations, everything. So obviously, depending upon the payload, the flight time will varies. So now we have a drones from 20 minutes to 2 hours. DGC approved drones currently available in Indian market. We can use of it. So payload compartment as remote sensing point of view, it has RGB. We can have then we can have a lidar. We can have a oblique sensor, which has five angle cameras. So it will provide a oblique, like a true textured 3D modeling. That is the latest trends is currently being used to create a actual photorealistic 3D model of any cities. Karnataka is planning to do oblique survey using five angle drones. So there will be 5 angle sensor. So they are 45-degree apart. So we can able to get actual texturized 3D realistic model, photorealistic model. It will be used for so many urban applications. So obviously these are other terminology we should able to keep it in mind. So what is takeoff, what is landing, so what is cruise? The cruise speed is, it is like autopilot mode. It sustains level at a constant altitude and speed. So it is typically autopilot mode. So waypoint, a waypoint is a critical inputs required for a flight as a automation mode. How a survey is going to happen, which area has to be looked. We can pre-plan it very nicely. So it will. So at the time of pre-planning, we can able to do a lot of checks and balance for safety of drones as well as data completeness. Whether we able to capture as per the required information, everything we can make it. So it is a pre-program on points and drone flight path for autonomous navigation. So a capacity of a payload capacity determines how big the drone can, how large weight the drone can able to carry. So flight time, so the payloads as well as the fixed, then the drone um, engineering will define the endurance. So what is industry typically single using single battery? How much duration we can be in airborne? So that is defined the flight time or endurance. So line of sight is very much critical. We have to follow DGCA guidelines. Definitely you must have learned or must have introduced in previous sessions about Indian drone rules and DGCA civil aviation guidelines. What are the red zone, green zone? So how much height we can fly? So which area is flyable, non-flyable? So everything, so then how it should be in the line of sight. We cannot fly a drones without out of our sight. So that is a critical requirement at the time of drone survey or drone flying. So it is for safety of our drones as well as safety of others also. So drones usually now they are called the terminology unmanned aerial vehicle, UAVs or UAS, with the sensors, payloads they called systems. So unmanned aerial systems. It is one more terminology we are able to look at it. So now we have to, there is a topic we have to discuss about the maneuvers, drone operation and maneuvers. Before that, going to that, we have to understand the fundamentals of flight, how the fixed wing drones is doing it. So we can see how the pilot can control these aerial machines and what are the different range of maneuvers available. So we should understand the interplay of four forces that is essential for fixed wing drone operation. They are lift, thrust, drag, weight. So there are four forces. It makes the drone airborne and it is for takeoff and everything. That is the four forces. So what lift does? It creates force generated by the wing shapes as it moves through the air, keeping the drone airborne. Thrust, it is a forward propelling force generated by the propeller to countering drag. The drag itself, the meaning, English meaning. So it is the force that opposes the drone's movement through the air. So if you want to slow down, the drag force will help us to do it. So the weight force is the gravity, the natural gravity, the force filling the drone to the chute. So the finally weight, the force of gravity pulling the drone. So it needs to be overcome by the lift for sustained flight. Maintaining balance between these forces is very crucial for the stable and controlled drone operations. So this is similar to aircraft maneuvers. It can so how the aircraft works. So we will have a small diagram. So we will understand the roll pitch yaw concept. So then we can able to understand the maneuver very easily. The control of an aircraft is comprised of three maneuvers. They are namely roll, pitch, yaw. The roll, it will rotate the wings right or left around the fuselage of the aircraft. The pitch, this is what makes the aircraft climb or descent. So yaw, this is the turning the aeroplane to left or right. So this maneuver points the nose of the aircraft to the right or left. So that is the continue. Each of these maneuvers are result of moving the control surfaces on the aircraft. So how we can do it this roll pitch yaw using three controllers. They are available. So there are ailerons, rudder, elevators. Ailerons control the roll of the aircraft. Rudder control the yaw. Elevators control the pitch. So using three these control things, we can able to maneuver the aircraft or fixed wing drone very nicely. So as I explained, fixed wing drone can perform variety of maneuvers from basic flight to more complex actions. We can have a combination of both basic maneuvers. If they're skilled, pilot will do a lot of complex maneuvers. So takeoff obviously, if at all not a VTOL, a simple throw or a runway acceleration. So depending upon the drone design, it will happen. Straight and level flight is the fundamental state of controlled flight. The drone maintains constant altitude and direction. So it is straight. It is like cruise, but it is not fully automated. Still, it is a manual control. So turns we achieved through a coordinate effort of ailerons and radars. So combination of that we can able to do. So what aileron does? It does the drone in the desired direction, while the radar controls the yaw, nose, or orientation to prevent slipping during the turn. So that is the complex maneuvers coming here. Maneuvers. Climbs are initiated by increasing throttle and slightly raising the elevators to gain altitude. So obviously, if you're reducing the throttle, we can lowering the elevators and we can initiate the descents. So these are the maneuvers. Once at least understand about the fixed wing drones. Now, one more things we have to discuss in this session is that what are the parts of fixed wing drones? So what a drone is composite? What are the 8 parts? So mainly airframe and wing, then tail, so then propulsion systems and ground control stations. So these are major components of a UAV or a fixed wing drones. So what a airframe does? It is a foundation of drone. The airframes provide a lightweight because it is typically composite material like carbon fiber or fiberglass. So it is provide a very good strength and it is a lightweight material. So it is giving the weight efficiency. So every components of drones will be inside it. So it houses all the airframe. The wing it generates lift. It is the primary force that keeps the drone airborne. So in the wings, the other like ailerons there, then it will have. We using that we can do other maneuvers. Tail will have I explained already. It have a radar. It have a stabilizers to control the pitch and yaw. So that the tail operation will do. So it so using that we can create a stability during flights, and we can do the directions. Now coming to the propulsion system, that is the mainly now almost all the drones are equipped with the electric. They are DC powered batteries. So it drives the drone forward, generating thrust. So obviously it consists of electric motor, propeller, and battery. The motors are we know what is for that. It will provide the energy for the propeller to rotate. So coming to the flight control systems. So it is the brain of the drone responsible for controlling its flight, comprises a flight controller, receiver, and transmitter. The flight controller receives and processes data from sensor to maintain stability. So all the commands, whatever earlier we talked, it all happened through the system. So these control systems will have one more major part. It have a ground control stations. I will be explaining that in the further slides. So it receive commands from ground. Accordingly, it will implicate the commands on the drones which is on airborne. So the receiver picks up signal from transmitter and relays that to the flight controller. The transmitter allows the pilot to send control signals to them. So flight control system, it is a controlling unit that operates the drone. So what are the components? So there are remote controller. It is a pilot interface for sending control signals to the drone. So what is flight controller? It is literally the brain of a drone. It processing sensor data and controlling flight surfaces. So sensor, they'll provide real-time data on the drone's orientation, altitude, and there will be IMU will be there. There will be GPS. So they will provide the real-time data on drones orientations, altitude, and airspeed. Ailerons control the wings. So elevators control pitch as it's ready for climbing and descending. Top is the rudder. They are. This is also part of control system that helps the flight to maneuver. So this is one more important component of called the ground control station. Typically, it acts as a mission control center for the drone operations. It gives a user-friendly interface for various functionals. So we can do using this. We can do the mission planning with waypoints. We will do takeoff landing points and automatic flight path. We will be able to switch over from different modes, manual, autonomous mode, or hybrid mode using first person view FEV kit. We can able to see the camera live feed and data recording. We will know about the situation awareness. So these are so it has a antenna that transmits everything. So every command we are providing, not only that, so it will act as the transmitter receiver, that is the data coming capturing on the drones sensor will be transferred to this antenna to the tab of the GCS or mobile. It acts as a control system as well as a data transfer system. So that is using 2.5 gigahertz frequency transfer. So mission planning. So mission planning is now what we are going to do with for this drone survey or drone surveillance. So what are our requirements? So we have to define it. So which data to be collected, whether it is a photography or mapping or it is for search and rescue. So we will define our mission plan accordingly. What is our area of interest, its locations, how large it is, whether one flight path is enough or we have to do multiple. So accordingly, how we can plan our flight lines. So what are the potential obstacles like terrains? So we have to follow, whether we have to enable terrain follow mode operations, or we have to feed a high accurate digital elevation model into the drone mission planning software for better movement. So what is the environment conditions? So weather forecast, wind speed, how the visibility, because the LOI's line of sight is very much required. And the locations, what is the flying restriction and what are the regulations of DGCA. So this is the four minimum the components that is required for planning any mission. So lot of free softwares available. Obviously, if you buy a drones with a photogrammetry payload things, almost all the manufacturers providing the mission planner. So better we have to use the OEM supply mission planner app or yes, software for better safety and more control systems. So after understanding our situation, what we have to do, depending upon the mode for mapping or surveillance, we have to plan the flight path. We have to do small research using other available data set like Google Map, Google Earth. So we can able to understand this, what are the complexity of the terrains. So other digital mapping tools, what is the, we have to mark it. We can use KML files to create our area of interest. So that we can, the flight path we can plan accordingly. So the in case of survey mode, if you give the area, most of the software automatically plan the speed, flying height. If you give the resolution, which resolution or which GST you want to capture your data, it will provide all the details. So accordingly we can plan. So they are not much complicated currently due to the technology advancement. So this is the waypoints what we are talking. So it is the main important things at the time of autonomous mode or any survey mode, what we want to do that. So on that, so it is the, it serves as guiding for drones to autonomous navigation. So ground, it utilizes the GCS software to define waypoints we can. So they are mainly GPS coordinates that mark key points along the flight path. Typically waypoints include takeoff points, that means there, then intermediate waypoints that guide the drone along the planned route. So it is a pre-planned route. They are nothing but they are the vertexes of pre-planned route, and we can design where it has been landed. So they design the landing zone, whether it should return to home or it should be landing at a different place rather than the takeoff place. All can be done using these things. So next flight, continuous flight, we can plan using the waypoints. So if there are multiple places nearby area the survey happening, so we can survey have to be going to be done. So each pockets we can plan the waypoints. We can feed it to the system. So without coming back to us, if we have enough endurance, we can plan 2-3 very properly without during the between the first area of interest to second area of interest. It will follow a straight path or a planned path. It saves energy, so it will not do any mode, any data capture other than flying. So all these operations can be controlled using drone control software through waypoints planning. So that is the important things I would like to emphasize. So we can set the desired altitude for maintenance during the flight. We can ensure it captures the necessary data while adhering safety regulations. So we cannot fly anything more than 120 meters as per Indian regulations, height above ground level. Above AGL we cannot fly. So that's why we can plan very perfectly to follow the regulations. So we can create a geofencing. All we can do that. So we can do camera settings if requires. That is more advanced things in case of if you want to do little different angle, if we want to capture the photographs, so camera settings required. Different resolution plan during times is required. Otherwise, if you give what is the overlap percentage, so what is your resolution or GST expected or the flying height, it will automatically calculate air speed, flying height, everything, even waypoints it will create. So the softwares are very capable of doing that. So obviously every mission planning before every flight, there are a lot of checklists available. It has to be strictly followed. as per the DGCA guidelines and safety considerations. So these are the repeating what we did. The basically how we navigate using ground GCS. One topic has to be discussed. So they are simple. So there are manual flight control, then automation, then geofencing, return to home. So the RTH is a very important requirement for any unmanned aerial operations, whether it is fixed wing or multi-copter. So it ensures that any loss of signals, okay, any unavoidable circumstances, any obstacles, so anything happen, it will safely return to the home. That home means where it is started, or we have, well, if you feed the location, this is home, it will use that. So during manual flight, what a pilot directly controls the drone's movement using GCS. They are, what is this flight control? They are mostly joysticks or a tab with the keys present on that. So waypoint navigation already explained. So it is used to fly autonomously the drones. Geofencing, yes. When I define my waypoint, so my drone will not fly anything beyond this area. So it is ensure that I have not violated to the any airspace, any privacy. I am not violating. That is ensured. If you do any manually, if you push also, it will not go. So the geofencing is one of the navigation techniques to we have to use it to control our flight navigation. So what are the pros cons? So obviously everybody knows the fixed wing drones is helpful for endurance. So their flight times are more. Their aerodynamic design allow to glide efficiently, so reducing the reliance on constant motor power. So we can glide it very nicely. So obviously it uses less power, hence it increases the endurance. So generally, if you translate to the flight times, it may be 3 times larger multi-rotor drones on a single battery of the same size. Then the range, obviously the range. What is range is how much that ground station can communicate to the drones. So that is how the communication is established without breaking. So that is the range of the drones or as well as controllers. So since I have a long endurance, I can make my controllers for a long range operations. So any the area that is dangerous, so I can stand far away, or it is not reachable, it is not safe to reach. All those things I can use for long range UAVs. So it leverage air currents and travel further on a single battery. So we can do, so people are using for pipeline inspection, search and rescue mostly for large area. That's why the fixed wings are used. They are used in army. Fixed wings very much used in the army. They are large drones, more than 25 kg weight to 150 or above 150. So payload capacity. So since it's free from the need of powerful motors for maintaining lift, it can carry heavier payloads. The weight of the powerful motors we can accommodate for heavier payloads compared to multi-rotors of the same size. So it is suitable for large camera systems, radar sensors. Radars are typically having more weight than other sensor system for or any other sensor. having more weight. So operating cost, it is little debatable. It is pros or cons. So it will be a positive depending upon our how our projects are going to how our project requirements. So generally, since it has a longer durations, so we can fly for a large area. We can cover large area at a time. So we can finish the task within a less duration. So it saves time and manpower or both. So obviously, it is the best aerodynamic efficiency than multi-rotors. Flight stability, that is also is a arguable point. In case flight stability is very good in fixed wing drones at normal conditions. In general, fixed drones are experience greater stability in wind compared to multi-rotors because of the aerodynamic. Okay, so it makes more them stable. But when the winds are very higher speed, so there the multi-rotors have more stability than the fixed wing drones. So what are the cons? Yes, obviously, if the VTOL not there, the VTOLs are little costly than the fixed wing drones. Definitely, we need a large area for launch and landing. So we need a small runway space to do that. So that is very there is major drawback if you are doing for urban or forest areas. Maneuverability, they are less agility, so we cannot turn as well. So this multi-rotor is we can turn, we can do the maneuver as per our requirement very easily. It controls, it acts immediately as per our control, but in the fixed wing drone we cannot do that because it is relies on forward airspeed. So for tight spaces or cities requiring frequent changes in direction, we cannot use it. So if you want to do inspecting very high complex structures or a terrain or rescue operations or a 3-dimensional mapping, so it is having a disadvantage. I explained already weather dependence. So they can handle moderate winds, but if they cannot, and the wings are having strong winds, turbulence. So it is their multi-rotors having the advantage than this. And learning curve. This assembling, dismantling, and flight controls maneuver, it is very complex than the multi-rotors. So operational, how to operate that learning of this operation, the learning curve is larger duration compared to multi-rotors. So more skilled manpower is required. That is the cons. So these are some Indian fixed wing drone manufacturers, RF unmanned systems. So they are then Garuda Aerospace. I'm just named. I may missed so more. Just I named a few for just understanding. So Idea Forge is there, SAG is there. So since we have a Indian manufacturer, so we have a technology advancements within the country, so we can use it proudly as well as affordably. Now coming to last application of drones. So drone has very variety of applications. Start from aerial photography, videography. So the videography everybody knows now. Every marriages, every mandabas, they are using it almost. So it is then wildlife. So they are capturing very beautiful moments for this all this tourism including Karnataka Forest Departments. They are using these drones for capturing a beautiful videos of animals as well as the landscapes. So they are putting it, so it attracts. They are putting it on various social platforms. They are using one of it for the same drones. Karnataka Forest Department having more drones. So they are one of the pioneers using drones for surveillance, mapping, as well as this kind of tourism purposes also. So obviously, private agencies using real estate. In India, it is less, but foreign countries it is are more. Mapping and surveying, that is major for urban, very, then mining, then infrastructure. These three major sectors using. So asset inspections, agriculture. So now this topic is more close to agriculture. So we are evolving agriculture in India by using drone technology. We are not a front runner, but in urban or other sectors, we are almost so many using it. That's why a lot of researchers IAS is doing. They have come up with a lot of different techniques, different methodology, different payload concept for precision agriculture, and NRSC doing it. So in agriculture in India, lot of activities going on. So crop spraying we can do. So many drones in India have having patent and they are DGCA certified relevant to this sensor. So we can do crop monitoring using multispectral with thermal sensor like parrot, and then live streaming events obviously. So we can use it for police using it. It is for safety, surveillance, and inspection. Emergency response. Drones we have used in Karnataka during floods, during landslides. So for damage assessment and search and rescue operation, there it was used. So disaster zone mapping. So we have mapped disaster occurred area. Mining. Karnataka, we are doing more than 3,000 quarries. Drone survey. So KSRSAC is technical partner for the DMG. We are doing it entire quarries using the drone survey. We are estimating the current level of the quarry, and we are using finally the volume and firefighting. And we are using firefighting not directly. We are using drones for identifying fires. So fire situation awareness, whether the fire in the forest fire happened. So forest department is using it. They are using for monitoring poachers. Obviously, it can be used for product delivery. Here and there, the product delivery concept is happening, but next 10 years, it is one of the major uses. Drone as a major component of delivery. It will going to happen. So I explained Karnataka, we directly use drones for forest area surveillance, forest fire monitoring. So we have a thermal sensor. So it is a dual payload also. So it is helping for animal tracking, illegal movement, poaching monitoring. So there are a lot of man-made fires during the summer season. The forest department flying drones, so that villages or the notorious people afraid to do make these fires, because initially the most of the forest fires are man-made. The natural is nearly 10% only. So it is helping forest department to do that. When that fire happens, so with the thermal sensor, they can able to detect fires, and it will provide accurate location of information real time. Obviously, this is has to be scaled up. It is not happening throughout the Karnataka. Major fire-prone areas, the respective heads are using it. The Karnataka department is very keen on, forest department is very keen on using it. So every year They are improving their methodology, improving the drone systems, their additional components, additional requirement, so that customizing drones are being manufactured on demand basis. So one of the Karnataka Forest Department is they are giving lot of lead input for drone manufacturers. So that is happening. So obviously it provides fire situation awarenesses. It provides fire dowsing status. So one of the important is the smoldering hotspot. When the forest fire, when the fire happens and doused, still few some areas there are hotspots will be there. But the manual check cannot be done those areas because the area will be having large heat, so no manually we cannot enter. So they are trying to use thermal sensor to identify those locations, then acting on the dowsing. Directly for dowsing, we are not at used. Like there are, we can equip the fire douse, the fireballs. They use this ammonia, so you can stop the fire. But that forest, it seems is a little large fire. That environment, whether we can use it, whether it is environment friendly, that kind of researches are going on. That can be used. So we can accurately map for forest fire loss of what are the loss and damages. We can do that, and we can do the regrowth monitoring. So like whatever earlier satellite we are using it. If we want to do more accurate, more precise area, that land forest is known for highly important species. So protected area, so there it is more friendly. So drone survey we are using it, as I already explained, tree level, post level, we can able to create vertical accuracy more than 20 centimeters. So we can create a model or an elevation model. So we use pre and post different terms, whatever at the time available. We can able to create the surface model. Then obviously we can do the volume estimation. Then I earlier explained due to using the oblique the sensor, we can able to create 3D reality model. So this is part of Mangalore, Karnataka government urban department is doing it. So they are planning to extend it for other urban areas. So mostly the property tax assessment and any violations of buildings, all is being measured and detected using these systems. These are few due to these are will get very photorealistic model due to the oblique sensor capability. So this is that's it. I think. So thank you. I am concluding my session. Any questions I would like to take it.
Thank you, Mr. Nagarkaniji.
Yeah.
Can you please explain about the any real-time projects you are doing apart from this, what you have mentioned in the presentation today?
See,
In case of
now we are planning to do real time now. Karnataka SSLR land record department doing a large scale mapping. So for resurvey, so resurvey purposes, this drone technology is very much used. Every bit of land of Karnataka, that means nearly 2 lakh square kilometers, is being covered by drone survey. So that helps to resurvey of our entire land records. That is one of the inputs along with the field survey. That is main. Then that is major. Now mines, obviously we have started fully involving in mines. Then urban. Forest already they started working for majorly for this Mysore division and Bangalore rural division. They are working with that drones very well, very well. As of now, these 5 major application we are Karnataka KSTA working directly. Now in agriculture, the department would like to use this drone technology, but we started with the fruits team, crop survey team. We started working on it, but we are not yet fully implemented on ground. That is the future that will be going to done for the agriculture related.
Thank you very much, Nagurji. If any other questions, I request all the participants to mention in the chat box, or they can give a signal. I will unmute them. Any questions? Okay, sir. Any words from Bhaskar sir? Any comments, feedback?
It's okay.
Okay, sir.
Yeah.
We'll end this session. Thank you very much, Nagur Kaniji, for accepting our invitation and delivering this today's session. On behalf of KSTA and Manage and all the participants, we heartily thank you, and we look your support in upcoming programs also. Thank you very much once again. So
Thank you all.
now we'll be having our next session by Mugilan Thiru Ramaswamy ji, who is with us and who has joined today. And I also welcome to today's session Wing Commander S. Somsundaram sir, who has joined with us from morning session. I noticed later. I welcome to you, sir.
Thank you. Thank you. Thanks for the.
So post lunch session, he will be taking a session on the case studies of drones and UAVs in real-time projects. Thank you, sir. Mugilanji, now you can take over. Thank you.
Good afternoon, everyone. Am I audible?
Yes, yes, you are audible.
Okay, perfect. So, good afternoon, everyone. Thank you again for inviting me. I think we had a good session yesterday, right? So today I am largely the topic I'm going to cover is related to mostly around the JS applications and a little bit on the software side of things, right? Where where I will be showing a little bit on the software that we have built, right? Yesterday was mostly what I was showing, largely around agriculture and sensors and so on and so forth, and payloads and which payload to use for which particular use case. Now I just want to show. I'm gonna take some time and show a little bit more on this thing, right? A little bit more on the software itself, right? Let me just share my screen. Again, I will not take too much time. I'll keep as much or more time for questions, right? So anyway, my screen visible?
Yes, visible, please.
Yeah, perfect. So very quickly, this is our software. So I'm going to show you what happens in case of once you fly a drone and after you fly a drone and you possibly collect images and videos. What actually happens, right? So what happens typically is when you after you fly a drone, you would want to upload the data. You would want to upload images. Whatever you collect out of a drone flight will be images. So before I go into images of uploading the data, one of the things people might ask, or when people have not flown drone itself, is how do you even collect data, right? So in case of flying, in case of collecting data for say an agricultural land or any other thing, we typically have a software called Drone Mission Ops. Anybody and everybody can download this software. It is available for free of cost on your Android phone and on the website. You can possibly download it and do exactly what I'm doing right now. It's not difficult. The website is app.dronemissionops.com, right? You can definitely go and check it out, right? And sign up if needed. right? So what I'll just very quickly show you what happens. So once you open the software, you'll basically have this screen. And if you want to go and map a particular agricultural site per se, right? In this case, what happens is you can possibly go and say I want to upload a site, or you can say I want to create a site. So in this particular, let me just go create a site. I go here, right? And I say I want to create a site. I say draw site, right? So typically you can say I want to draw an area where I want to fly, right? So in this case, I say I want to draw this area. I'm gonna very quickly draw an area, right? So say this can be an agricultural land, it can be any particular area, right? I'm just going to go is going to draw a large piece of land, right? So and what you can see in terms of yellow circles and blue circles over here is the regulatory clearance, right? So in some cases where there's an airport over here, you're not able to, you're not supposed to fly, right? So that's something which is over there. But I'm just going to anyway go ahead and say map out. As you can see in the right hand side of my screen, I'm just drawing a polygon, very random area. This is about 869 acres of land. I say confirm area, and I this is for a demo, right? Once I do this, right, and I want to map this region 869 acres, I'm saying I want to map, right? And I can possibly choose any drone model, right? I can choose different drone models are there. Indian drones are there, foreign drones are there, different types of drones are there. You can possibly choose this. And after doing this, this basically will, tell me, okay, how many images I am going to possibly, generate or create while I'm doing this. I'm just saying, okay, this is the number of batteries I have. This is the drone speed I'm going to use. This is the drone I'm going to fly. So here you can see there are about around 2,155 images that are going to be collected for doing a mapping of this region. Right. So around 2,155 images are totally getting collected. Right. There are two flight times. First flight time is about 2 hours. It will take me to cover this much area, and it will take me about 1 hour 30 minutes to cover this much area. Right. So essentially in about 3 hours, I will be able to completely map out 869 acres of land. Right. And once this in 3 hours, I'm going to do that. It is the average resolution is about 3.5 centimeters per pixel. Every pixel will have 3.5 centimeters, right? So once I collect these images, now you can be like, okay, now I spent 3 hours, I go there, I do this mapping. If you have an Android app, there will also be a button called fly where you can actually fly and you can actually collect these images, right? So once you do this, it's as simple as this, right? Now we just did a mission planning of a drone for mapping out 869 acres of land, right? In matter of few minutes, right? And after doing this, what happens is once you collect these images, you come back here and then you basically say, I want to upload all these images, right? So you can go to Spectra. This is our software again, Spectra. You can again go. It's available online. You can definitely go here, and you can again create your own project, right? You can create a new project, and what happens? You say definitely, right? And then once you create a project, you will be asked to upload. You will be asked to upload, right? Let me just create a survey. Survey 1, right? You will be asked to upload your images that you collected last time, right? You upload those images. So I don't have any images over here, but if I were to just, very quickly upload some images, right? And I click upload and I click process, the images will get fully processed and you will basically get so this simple example where images are getting uploaded, right? So I'll just show you what will happen. So so this is a set of images which we have already uploaded. There are 101 images and there's 700 MB, right? Once you do this, you click on process, right? Says processing complete. So you can basically go here and see what are the outputs which are there. You'll get an orthomosaic, you'll get a point cloud, you'll get different outputs over here. You can of course download these outputs. I'll show you how these outputs kind of look, right? So if I were to go here and once I do that, this is how a drone map actually looks, right? So in cases where people have not seen a drone map, right, you can see there's about usually around 2 to 3 centimeters per pixel, right, of resolution. Extremely accurate data, and this can be, again, this just the normal images which is giving you this level of accuracy. You can of course have other sensors, and you can figure out what are the other things which are possible. But just with normal ortho, for people who have never seen a drone map, you can see how accurate this particular map looks like, right? So this particular map, you can also do a whole bunch of GIS tools and analysis. You can see, you want to measure this rooftop, you can definitely click here and you will be able to measure, right, what is the length. We can say this is the length of this is about perimeters about 800 inches, 87 meters. You want to measure the area of this roof, you can measure the area, right? You can measure tree canopy. This is about whatever 294 whatever square meters, right? You want to measure you can measure this canopy of this tree, whatever, right? You can keep doing a whole bunch of different analysis. So one of the other things that was possible, I think yesterday a candidate was asking me questions around, can we build AI on top of this data? So of course you can. There are different ways of building AI. In this particular map, I will show you some of the AI things that we have built, right? Like for example, here we have built tree count, we have done vegetation, we have done haul road analysis, etc., right? Road analysis and whatever. So if I were to very quickly say possibly run a building detection model, so I say I want to run this entire building detection model on this entire auto, right? And I want to possibly run tree count on this entire auto. I've also done this in the past. It will take 5-10 minutes, but for the sake of time, I'm just going to very quickly show you how a building AI looks, right? So this is how once you train the data, this is how you can automatically detect all the buildings, right? So as you can see, this is how all the buildings are automatically digitized, right? Without actual manual digitization, these are the digitized buildings, right? In a particular area of land, right? And you can also do a automatic tree count to see, you can automatically detect, okay, which trees are there. For example, there's a palm tree which is automatically detecting all the palm trees, right? You can of course train it for variety of other trees or variety of other vegetation or whatever else, right? So you can of course do that for different you know you can, for maps and AI, you can possibly do, right? This will give you a good sense of saying that if you have an orthomosaic, you can possibly train uh, uh, this particular data to get whatever insights you possibly want, right? So lastly, I just want to show you, other than this, I want to show you very quickly some level of how multispectral data actually looks like, right? Let me just see whether I have some multispectral. This is an elevation map. This is not multispectral. I don't have thermal. I don't have. Okay. So let me just show you thermal data, right? So for people who want to see how thermal data actually looks like, right? So this is typically how, for a solar panel, when you're doing a drone mapping of solar panel, this is how a thermal orthomosaic actually looks like, right? And you can possibly see, how the variation is, right? So these are the regions where temperature is greater than 50 centigrade to about 83 centigrade, right? Let me just 50, right? So yeah, As you can see, the grounds are not, is not so hot, right? The panels are more hotter than 50 degrees Celsius, right? So that is something that you can easily see, right? And in some cases, you might have, higher hotspots. Like in these kind of cases, you can detect, say, you can see, oh my God, there's more than, what is the ambient thing, which is a defect in a particular solar panel, right? Of course, this can be used for moisture, it can be used for, other, possibly so many other things, right? But you can see the point temperature over here is about 58.84, right? So you can clearly see there are in some cases, there are hotspots, right? In this particular case, you can again see there's an entire panel over here in this region, which is little bit more has defects because of a because of a thermal outage, right? Or a panel defect of sorts, right? So this is how you basically do, thermal mapping. Okay. So other than that, other than saying you want to see thermal, I'll also show you how a 3D map actually looks for a particular drone, right? So in this particular case, let me just very quickly show you if the same thing in 3 dimensions, the same, possibly how a 3-dimensional map kind of looks using a drone data. Right, so this is how this is all our loading on the web. So you can also see this is the resolution you get in 3D. Right, this is a particular mine. Right, so you can clearly see, what is the resolution of a particular mine. This kind of data in the last, only was available in the last 5 years of sorts. But usually what happens is you can clearly see this was not there about a decade ago or something, all those things. Right. So if you want for any miner or anybody who's actually in the mining field, you will kind of know that this is very highly accurate data and very useful for your mining operations. Right. Again, this is done by camera. If you want more resolution, you can also use LiDAR for it, but you'll get similar outputs. Right. So here you can also see what if you really want to know what is the elevation profile, all you need to do is click, from here to here, right? And it'll, okay, let me go back to 2D. So that's easy for me to possibly connect the point. Yeah. So I can easily, possibly do the elevation profile of this, right? So I just say, please give me the elevation profile of this particular region, and it'll tell me exactly, okay, it's starting from, 547, but it's going all the way down to 521, 522, and all of that, right? So those are things which are very easily possible. The other thing is when you want to, if you really want to measure the volume of a particular area. So in this particular case, if you want to measure the volume, this is the approximate volume, right? There's about compared to previous survey, there are about 3,000 odd meter cube of land which is excavated from you, right? So you can of course measure, different volumes. So for example, if I want to measure what is the volume of this particular, pile over here, all I need to again do is, it's a very simple tool. Like I think people who have done GIS will do the same thing in ArcGIS or any other, possible, other softwares. But the web-based software is again very simple to possibly sit and compute volume of, different regions, right? So very quickly, I can possibly say, okay, this the volume of with respect to the ground surface about 3,655, right? It took hardly any time to actually do this, right? So that's mostly what, drone data can be used for. I just wanted to very quickly show you some land-based mapping. Of course, I can go on and talk about, power in what are the use case and power transmission, other assets of sorts. But as you know, it's a very simple, tool using drone data to possibly do a whole bunch of analysis of sorts, right? So that's something which I wanted to, talk to you about, right? Very happy to answer any further questions. I on this topic, right? So what I wanted to cover was basically how easy it is using some softwares to possibly fly a drone in any piece of land, and second is to also analyze the drone data, all the images or the videos that you collect into a particular map, and also run AI analytics or do some JS operations on this, right? The accuracy for all these maps are around 3 to 4 centimeters or 5 centimeters, even lesser in some cases. But so hence you can only imagine. I encourage everyone to imagine the possible use cases of having this much accurate maps and different sensors of sorts. All right, so that's all I had for everyone today. Would be happy to take any questions and show you anything else if you guys have.
Ranjit, any questions? I think there is one question in the Q&A section. Mugilan, can you see that? Shall I read?
Let me just quickly open the question. I'm not able to see that. Yes. Today India needs for question. Today India needs so much food that is perishable, non-perishable, doing very hard in the country. What type of solution can you provide as agri expert from your end? All these mapping software are very expensive. How can a normal farmer get all these services in a rural area? Right. Okay. So good question, right? So most of our customers in the agricultural field or any other field have been corporate companies, right? We've in the past worked with Syngenta and past worked with so many other larger corporate companies for doing this analysis. But the softwares and drones are becoming very cheaper and cheaper as we speak, right? So typically what happens is there are a lot of agricultural services companies who are offering insights to farmers. Like usually what happens is there are services companies which are there which do spraying as a service today, right? And tomorrow what we believe is the fact that similar companies at a village level, there might be some agri expert who might own a drone, who might own these softwares and offer this as a service to individual farmers for a fee, right? So essentially what happens is, so for example, if you want to give any agri insight, right, saying how many plant count is there, or what is the area of your particular land or something on those lines, it can be as simple as something for 200 or 300 rupees per acre for one-time reports, right? Or sometimes it can go up to say about 500, 600 rupees per acre, right? That's typically what the cost is, right, for doing any sort of analysis or insight, which will also lead some level of profit margin for the service provider, as well as the entire, and can derive that amount of value for the farmer as well, right? Today farmers are paying, or or even farmer agencies are paying about 300 to 500 rupees per acre for spraying the land, right? So I think that is how this entire ecosystem is going to evolve, right? When there'll be a lot of individual service providers in different villages or different districts, maybe offering these services, offering these value as a service to multiple farmers. I don't think we are going to see a time in the near future where farmers themselves will purchase a drone, and they need not actually also purchase a drone, right? Because they're going to use it only once in a while. These are not things which are it's not critical for them to own the drone or actually know to fly and whatever else, or even use the software, right? These are usually built for professionals like other agri experts or other service providers to use the software to give end value to the farmer, right? I hope I answered your question.
Thank you. Any other questions? Please give the link to download the app.
Yeah. So you can check in Google app.dronemissionops.com, right? I'm just going to, this is the app. And you can also check.
How many image styles will the web interface allow at one go? Any limitations?
No limitations at this point. We have done close to 10,000 acres of land in one shot, right? So there's no limitation on the number of tiles. We are tiling everything on the web, right?
What are the challenges you come across related to data management, storage? What will be the capacity of a single image tile? And how
So
many
this is all hosted on AWS. So there is no actual restriction of sorts. It's all cloud based, right? So
Okay.
it has no actual restriction in these cases.
Fine, thank you. Any other questions? Any other questions from the audience? Som Sundaram sir, any other feedback or comments on this session, sir?
Yeah, nothing much except that, yeah, in case if students have or the participants feel that after listening to last 3 days, if they have any questions regarding drones or based on type certification, because there was a class on type certification I could see, then on manufacturing of drones or anything like that, I'm willing to take on, because being a part of evaluator who is doing the type certification for DGCA, as well as being an entrepreneur myself, if anyone has some doubts on this, I can answer now. And even if it is after the session also, I can do that. So I'm open for that.
Thank you, sir. Thank you. There are few questions. A few of the audience would like to have a training for DGCA certification. Regarding that, you can tell after your session in the post lunch.
Anyway, I'll be covering that part in my this thing also, because after all this session, after 3 days,
Yes, sir.
I can understand the curiosity of the participants, that what is the next. Okay, they have attended a session, what will happen to them, how can they go ahead on this. So as far as the certification is concerned, for if it's a pilot certification, then there is a procedure to get into go and get trained on in RPTO. Okay, so if you go to RPTO, then it is a paid service. Okay, so it varies from anywhere from 15,000 to 35,000 as of today in India. Okay, so they can go get trained there. Second, there is a provision by Government of India at IIT Mandi where people can get trained free of cost, but it comes under Skill Development Authority of India. So there is a procedure for it to apply. So people can apply directly to IIT Mandi, and they get shortlisted. So they have a batch of approximately 30 students in a span for 45 days. It is a long course, unlike the RPTO course. Generally, the RPTO course is just for 5 days. Okay, and most of the time after you come out from RPTO, you may not be able to fly the agri drones, because today we are focused on agri drones. So it takes another 15-20 days of extra effort to fly with another agri drone expert to get used to agri drones, because agri drones are huge in size. Okay, so they are at least 1.1 meter and above. So with that as this thing, so this course which has been done at IIT Mandi covers a huge thing in terms of giving you exposure to flying, plus also to understand what sort of chemicals can be used in the drones. Okay, because all chemicals cannot be used in the drones. There are specific chemicals which can be used, and what quantity you should use, what is a mix and match you can use to ensure that you get the best result in the drones. So it is a long course of approximately 30 days plus. So that is the second way you can get certified. Third one is now with especially for women pilots who are very keen to become women pilots. So there is a program called Drone Didi, which has been initiated by Government of India. Okay, So in this program, so women are getting trained. Approximately 19,000 women are to be trained in next a year or so. Out of which, in the last year, just before the elections, they have covered approximately 2,000 plus women pilots. But however, approximately only 17,000 pilots need to be trained. So for which the government is going to pay this, or there are agri-tech companies which have taken the cue to fund this whole project. Okay, so this project, if the participants are keen, they need to be on a lookout. Okay, on some newspaper ads and announcements in the most of the media that this program is going to start once these elections are completed. Okay, so in fact, Mahindra and Mahindra has tied up. In fact, it is as latest as yesterday that they have tied up, and they have been probably going to get the biggest bunch of training. So that is 15,000 women have to be trained. So that complete thing Mahindra and Mahindra has bagged from the government. So how they are going to launch and all those things all depends after the elections are over. So this is another place where few of the participants, especially the women participants, can get trained free of cost. There is no money for this because government is going to bear, or alternately agri-tech companies are going to bear. So these are the three ways a person can get trained as of today and get a valid license.
Thank you very much, sir. So on behalf of KSTA and on behalf of Manage and all the participants, I would like to thank T. Thirumugilan Ramaswamiji once again and Somsundram sir. So now we will be having a lunch break. After that, 2:30 we will be assembling back here for the last session by S. Somsundram sir regarding the case studies and real-time projects they are handling in the agriculture field. Is that fine, sir? At 2:30 we will join here again back.
Yeah, right. Thank you.
So now we will be having a lunch break. I request all of you to join by 2:15. So there will be few announcements made in the chat box. Okay, regarding the workshop. Thank you. Thank you very much.
Thanks.